Good morning from Germany. My name is Alexander Prange from the DFKI, and I'm happy to be here today on behalf of my co-authors, not only from DFKI, but also from the Charité in Berlin. I'm a PhD student at Saarland University, and I'm a researcher at the DFKI, which is the German Research Center for Artificial Intelligence. And we like to see ourselves as the leading research center for innovative AI software technology in Germany. And my group is situated, or the group I'm part of, is situated in Saarbrücken, Germany, which is at the border to France. And I'm working in the interactive machine learning group, IML. And if you want to know anything about our other projects, feel free to visit us. So what I'm talking here today about is the Interact project, or part of it. And there we aim at digitalizing neurocognitive testing, which is relevant not only for research, but also in the medical domain, in screening programs, in the detection of dementia and other cognitive impairments. And the mini-mental state exam, because I think not all of you know that, because you are too young, it is a 30-point questionnaire, and it's used in medicine and research to measure cognitive impairment. It's usually administered by a trained professional. So you go to your general practitioner, for example, if you are experiencing signs of impairment or you experience some impairment with your relatives, you go there, and this is then a screening tool that is done with you where the practitioner sits on the opposite of you and asks you a few questions and takes notes of it. Later, the professional then manually evaluates your answers and how you performed the tasks during the MMSE. And on average, this takes around 5 to 10 minutes, depending on the skills and experience of the professional. Due to its standardization and a short administration period and ease of use, this is used internationally, so it's been translated to many, many languages, and this is not only relevant for English, but also to many other languages as well. To give you an expression, how this works is basically there are some orientation questions. You are asked about where you are, what time is it, to see if your orientation still is in check. You are required, for example, to name a few items. You are shown a wristwatch and a pencil, and you are asked to just say the words that you think these objects are. There are a few more tasks concerned with speech and memory. So, for example, repeating a few phrases, trying to remember some words, which you are then later asked. And there is also a part about handwriting and sketching, where you are required to copy a complex, more or less complex figure, and write a sentence on a piece of paper. What the professional then does is he takes notes, and afterwards there are points awarded for each subtask. Basically, it's a 1-0, you were right or you were wrong, and it depends on the task how the points are distributed, but after all, you sum them up and you get a total score, which then gives you an indication about your state of impairment, if present. Just let me note here that this is a test that is usually not working with healthy people, in that sense that you can, if you reach 30 points, it's 30 points, so it's the maximum. But you can't really, this test was designed actually to measure below. It's hard to explain. Yeah, but usually below a certain threshold, which is around 24 points, it is considered to be some kind of impairment present. So, now to our contribution. We realized the MMSE as a multimodal speech-based dialogue, and basically we managed to completely digitalize all tasks of this test, and we are now able to evaluate the questions that you were answering automatically, and we are also able to analyze the written and sketched parts of the test that you were doing. which gives us an automated scoring system, which reduces the caregiver's time for this step to 0. And in addition, we get a very objective analysis of the results, because usually with cognitive testing or assessments, there's always the problem that depending on your practitioner and his experience and when and how he learned this specific assessment, there's always room for biased results, so subjective interpretation of certain things. We did a HCI user study with 15 participants, and we compared the automated scoring of our system versus the manual scoring, which was done by a professional. And we have currently work in progress, which is a larger evaluation at the geriatrics daycare clinic. So how does this look like in our study? We have 3 devices, basically. We have on the upper left, you see the Google Home Mini. We have a smartphone, which is needed to have the digital pen attached. And we have a stack of pre-printed paper. But I will explain that in a second. So first to the Google Home Mini. Some of you may have this at home. It's basically a microphone and a speaker device, which is quite cheap to buy. And we thought to use that to have a wide range of accessibility, because we think that this design could be used in the future, for example, at home, so that you don't even have to leave for the practice and you could repeat this several times a year, for example. There is, via the online service of Google, you get ASR and TTS for the actual speech. And then you create, via an online API, you can create kind of a question answering dialogue. Well, the problem here was that we expected to use this more or less as an input-output device, but the way that this dialogue flow, the Google online service is made, it is more or less for simple question answering. For example, you're booking a reservation at a restaurant, so it's always very short, just system asks you, you answer something. And so the problem here was that the MMSE is a more complex task, and therefore we needed to adjust or to replace basically the entire dialogue management and do it ourselves. And I will have a slide for that later. First, also to the other hardware, which is the digital pen. This is basically just a normal ballpoint pen, which has a camera in front, and you have a printed paper, which has a very almost invisible pattern on it, and then you just write like with any normal pen. But the data about where you are writing is then streamed via the smartphone to our system, and we get X and Y coordinates, as well as pressure and timestamps, which we can then analyze, for example, for the writing and sketching tasks. From the architecture point of view, we have 3 main components. We have the speech dialogue system itself, we have the smart pen with the paper, and our backend service. As you see at the top, we have 2 main modalities, which are handwriting and speech. And both of them are then fused in the backend server, where we are doing handwriting analysis for the actual handwriting, and we are also able to replay your handwriting as you have done it in real time, so that the practitioner later can even have a look at how you've done that. For the speech, we replace the dialogue management by hooking into the Dialogflow API and having the intent resolver and response generation with the dialogue management. So the results of both, basically the transcribed content of the speech input and the transcribed content of the handwriting input, are then used for automated scoring, and you get a nice exported structured format, and you can also export it as a PDF, for example. And all of this is done automatically and in real time. So the implementation of the MMSE itself is basically, in our example here, in the first part you have the interview questions, and the device takes you through it. It greets you, and then it asks you the questions, you answer, and it continues to the next. For the second part, basically there is a prepared stack of paper in front of you, and the system asks you to, for example, turn around a page, and then on the page you see a pencil or wristband, and you are then instructed to say what you see. And same goes, for example, for the writing and sketching. You turn around the page when instructed by the system and do the task. We have the possibility of clarification questions like, what did you say? Or can you repeat that? It depends if there are certain cases where this is not allowed in the task design of the MMSE itself. For example, if you are to repeat something, there is a specific rule basically in the test that says you're not allowed to repeat that more than X times. And we have added this also to our implementation. So for the automated scoring, basically this is a one-to-one realization of the existing scoring scheme, which gives us the benefit that this is already validated and used in this way already in practice for many, many years, and we're just doing this one-to-one. So the spoken answers are basically just check for correctness, the current time of day, the place you are, and the items you name, etc., etc. And for the analysis of the digital ink, we have on the one hand handwriting recognition, for example, when you write the sentence, or we are also using a set of more than 100 ink features for analysis of your actual writing. These are more or less like geometric aspects of your handwriting. You can do a lot with angles, you can do something with velocity and everything, and we are analyzing the behavior of your handwriting as well. So for the user study, we compared the traditional version with the automated system. Here I'm presenting an earlier study with 15 participants, 5 of which were female, 10 male. And the age was between 19 and 75, but we tried to concentrate. So we had 5 elderly from the geriatrics clinic who were diagnosed with no impairment, and the rest was from our colleagues at work and university, and there we tried to focus on people who are close to retirement, in one case even a retired professor. So there were 2 modes per subject. That was done in German, but as I said earlier, this test is available in many languages and it doesn't differ a lot. So I think that the results here are also you can transfer them to any other language. We had 2 modes per subject. We had human test run and automated. We had 3 different testers to avoid the bias that I was talking about earlier. And we chose at random basically who starts with which mode. And after each mode, we asked to fill out a system usability scale and a user experience questionnaire. All experiments were done in a quiet and distraction-free room while the participant was sitting at the table. So the results, we are quite satisfied with the results because the completion time for the participant, for the subject here, is about the same for both cases. So this means we add no additional overhead for the automated system, but we reduce the time for the caregiver to 0. So we have already a benefit here. Both systems scored equally on the SUS with the score good. And for the user experience questionnaire, we see no clear differences except for novelty, where the automated system got a bit higher marks. Regarding the scoring, so we had a professional score and an automated system score. We compared these scores and we found that in 21% of cases, both human and system scored exactly the same. And for almost half of it only differed by 1 point. When we analyzed the individual results, it turned out that the biggest discrepancy were in the spelling task, and there was the problem that basically the input-output of the Google dialog was not able to correctly identify spelling. So it always tried to interpret some strange words into the spelling. And that's why there was always basically a difference in scoring there. And the other differences are also related to the speech recognition part. So in conclusion, I've presented you our work on multimodal speech-based dialogue for the MMSE, which is only one example. You can also use same techniques, for example, for other assessments, including the more popular, currently becoming more popular, MOCA. We have a real-time automated scoring system that is based on an existing one. And we are quite satisfied with usability and the easy deployment. For work in progress, we are currently doing a larger study, and we are trying to apply this, as I said, to other assessments. Also, we try to include different modalities, for example, electrodermal activity, which can give you feedback about, for example, stress indicators in certain tasks. So I would like to conclude on the note that we are always looking for collaborative partners. If you're interested in any kind of research in that area, please feel free to visit us at our webpage. We have a lot of projects going on, not only in this domain, but also in other areas. Yeah, thank you very much.
Hi, Rens Markert from TU Eindhoven. Thank you for the great work. I work with the target group myself, and I think it would also save us researchers a lot of work to have a digital version of the MMSE. I had two questions. So the first question is, do you also have some qualitative results on what the difference in experience was for the participants between the human test and the artificial test? And the second question is, do you think the SUS, so the SUS has been criticized because it's based on recall to use with impaired users. So how do you want to evaluate it when you're actually going to do the clinical test with impaired users? Because I think the SUS is then maybe quite challenging for this group.
Yes. So to your first question, yes, there was a lot of feedback, but I didn't have basically time enough to include this here. Overall, the essence was that people tend to enjoy more the human contact, but this is not due to the bad experience about speech recognition systems, but more or less just because of the human contact. The other part was basically that most of them could actually imagine that this would be used in the future, so they quite liked the idea themselves, and they were also interested, so the elderly people were also interested in the technology as such, and we felt that there was no clear disadvantage in using that, so from the feedback that we got. For the other part, we hadn't quite looked into that in detail yet, but we are currently in the preparation phase for another session of the study, and I actually will consider that then. Yeah. Thanks.
I have a question. Older people tend to have comorbidities, so not just one condition. So I was wondering, you said you were doing a larger study. Are you including those type of people in your study, and could you tell us just a little bit more about it?
Yes, so we had already some interesting experiences regarding, for example, what's the English word, arthritis or something, where you have problems with your joints, right? And there, for example, it was difficult for people to hold the pen. But this was more or less a general problem, and people adjusted very well to that. We had the usual problems with bad eyesight, for example. And yeah, you're right, there are different...
I was thinking after stroke, for example, because you're using speech.
Yes. So basically, we are trying to look at people who are not yet in the full stage of any kind of impairment, because we are focusing here on the use as a screening tool. So, yeah.
Is there any other questions?
Hi, thanks for this. This is a very interesting talk. My name is Pin Sim. I'm from National University of Singapore. I have a question about, we've used the MMSE with our target population as well, and a lot of times the judgment about how accurate the answer is depends on the person administering the MMSE, because sometimes you have that variance in total recall, how accurate it is, and things like that. So I was wondering whether there were any plans to address that, perhaps for the later iterations with the clinical population, and how you would address that.
So our take on this is basically that by doing the objective automated analysis, we can circumvent this effect entirely. And more or less, we are only doing the human tests or the traditional version to have a direct comparison with our system. And there we try to cope by adding a variety of testers, basically, to get rid of this bias there.
Do we have any last questions? Oh. Okay. I'd like to thank all our speakers this morning, and that draws the